this is the part 3 of embedded system lectures. We are going to see about the software components and the important terms or the tools that we are using in the software component or the software design. Okay, so we are going to see all those things in this video. We have already done 2 parts on embedded system. First one is embedded system introduction and the characteristics. Second one, we have discussed the hardware components. Along with each part, we have discussed the important questions which can come from that area, because these videos I'm mainly doing as for semester examination and also for interview preparation. Okay, so that's why I have included important questions towards the end of every part. Okay, so what is a software? So software, what is a software that we use in embedded system? We all know that embedded systems are application specific. Okay, so they will be performing a specific task or an application. So for this case, we are using an application specific software. Okay, we can say that the hardware is the heart of an embedded system and the software is a brain of an embedded system. Brain means, we all know, just like in our body, brain is actually controlling and coordinating everything, right? So the functioning of the body is actually based on the brain. So just like that, the software of embedded system is a brain of the embedded system, and it is the plans and the rules based on which the embedded system is actually working. Okay, the system specific instruction code and data at the final phase are placed to the ROM or flash memory. So this term is very important. So the program code of an embedded system is actually placed in which memory? It is placed in either ROM or in the flash memory. 90% of the time it will be placed in the ROM, and the name of that final phase of data and code based on which the embedded system is actually working is called ROM image. This term is very important. Okay, so when you are writing the examination, you should definitely write this term. So after doing the coding for embedded system working and everything, we'll make a final code and we'll combine it with the data, and the final phase has been burned to the ROM or it is been kept in the flash memory. So since it is kept in the ROM, and that is the final code based on which the embedded system will actually work, and this code is called ROM image. And also along with the ROM image, there will be a file that we'll be keeping, and in that file there will be 2 columns. One column will be the address, second column will be the corresponding bytes stored in that address. Okay, so the address of the every byte is also being kept along with the ROM image. Okay, so the ROM image is also consisting of a table or a file, so we'll call it as a table. Okay, and a table with address, location and the byte is also burned to the ROM image. Okay, each ROM address is allocated with bytes or bits. Okay, so if you talk about the embedded system software, so the embedded system software is only the required amount, only the application specific software we are using, and also the final code or the final data for the working of the embedded system is being kept in the ROM. It is called ROM image, and along with we are keeping a table which is having the address location of the ROM, various address locations, and also the data that is present or the byte that is present in each of those address location. So we'll form a table and we'll keep that along with the ROM image. Okay, so this is the software. Next let us see the various types of codings that we use in embedded system design. The first type is machine language type. So this is the most primitive type of coding. Machine language means ones and zeros. So only these ones and zeros are known to the any processor. Any processor is only understanding ones and zeros. Okay, so based on which if we are doing coding, that is if we are writing the code in ones and zeros, it is called machine language coding. But that is actually very an non-practical method, because we know that humans cannot do that much of really complex coding. That is very difficult. Okay, next type of coding is called assembly language coding. So we write the codes in hex format, which is called assembly language. So this is assembly language, means it is The hardware specific or the processor specific type of coding is called assembly language coding. Generally, we do for 8051, we are doing hex files, like we create hex code, right? Hexadecimal coding. That type of coding is called assembly language coding. The third one is called high level language coding. So high level language means C, C++, Java. These type of languages are called high level languages. So these are more human understandable languages. So if we are doing the coding based on this high level languages, it is called high level language coding. Okay. So most commonly we'll be doing either assembly language or high level language. Okay. So first one is assembly language coding. So here we are going to write the code in assembly language. But in order to burn to the hardware, we have to first convert that to a machine code, because the hardware or the processor will only understand ones and zeros. For that case, we have to first convert the assembly language. See, for our convenience, we are actually using assembly language. But the processor is convenient with ones and zeros. So we have to convert that assembly language, which we have written, to the machine code or the machine language. For that, we are using an assembler. And this process is called assembling. Okay. Next, let us see how an assembler and assembling is happening. Okay. See, I hope you can see the images. So here, if you see that this is the assembly language program which we have done. In the arrow, I have put a 1. So there we are actually using an assembler. So the assembly language codes which we have written will be first converted to the machine language or into machine form, and then we are going to reallocate the address, and the machine codes are ready to be located at various addresses. Okay. Now in the assembly codes there will be some library functions also. Okay. There will be some predefined functions that we will be using. So for that case, we have to also use linker. There is a linker, and the linker is actually doing the process of linking. Well, later on we'll be discussing about these tools like assembler, linker, everything in detail. But just know that linker, it is actually combining various machine codes. Or if there is a predefined function that we are using in our assembly language, so we need to find the meaning or the definition of that predefined function. So for that case, we will be using library files, and the linker will be actually fetching this definition of the predefined functions, and it will link the definitions along with our machine codes. Okay, so the linker will, from the library, it will take the needed code, and then the bytes will be linked to the program, and it is again given to the machine codes. Then next one, so our machine codes are ready now. See, the first path is this, through which the assembly language program is coming. First, assembly language program is converted to machine codes and then formed machine codes. Then along with that, the predefined functions, machine codes or bytes are also being linked. Now it is ready to be burned to the ROM. So this is the final code. And next thing we are doing is burning to the code. For that, we will use a device programmer. And with the help of that, we'll program the ROM memory. Along with, we are giving the data bytes. So what all things are we combining here? First one, the assembly language code. Then the library files or the library functions, its definitions. There is a predefined function definitions. Then the data bytes. So these things will be given to the data is actually given to the burner. And all the three things we are actually burning into the ROM image. Now we will get a ROM memory which is programmed, which is called the ROM image. So here we are actually burning all these things, or we are actually writing all these things to the ROM, and we are getting a ROM image. Okay. So this is how the assembly language coding is done. So in simple words, I can explain to you that you don't need to by heart this this block diagram or anything. You just need to know the concept. Okay. So in assembly language coding, we are actually writing the codes in assembly language, but the machine is not understanding this assembly language. So we are going to convert the assembly language to machine code or machine language. Now in this assembly language coding, there will be some predefined functions. So in order to write the definition of the predefined function, we'll go to the library files. From the library files, we'll fetch the definition, and along with the machine codes, we'll be attaching these definitions also. These are also in the binary numbers, that is ones and zeros. Okay, the definitions are also in ones and zeros, so we can directly attach that to the machine codes. Okay, so the linker will take the bytes and attach to the machine codes. Then this machine codes is given to the burner or the programmer. Along with that, we'll be giving data bytes also, and then we'll be burning these things combined in a combined form to the ROM. Okay, then we'll be getting our ROM image. Okay, so that's all about the assembly language coding. Next one is high level coding. So just like I have said in the beginning, we are going to use C, C++ or Java. And here we are actually using a compiler. Here again, the language is, the programming is done in high level language. So for making in the machine understandable form, we have to first convert that to the machine code, right? For that purpose, we are going to use a compiler. Next, let us see the image of a compiler. Here you can see that we are going to do the programming in C or C++. Then we'll be using a compiler. Then it is converted to the object file, which are in ones and zeros. Then it is given to the linker. In the linker, some library files or predefined functions are being attached along with these object codes, or it will be simply combining the three object codes. Okay, even if there is no predefined functions, the linker can also perform another function called combining of these three object codes. Then it is given to a, then it is relocatable and it is given to a locator, and then we'll be getting an executable file. Now we'll be seeing what is a locator and all later on in this video. Okay, so just know that here the thing you should be knowing is that, see, the coding we have done in C, C++. Along with that, we have also mentioned one assembly language coding also. Just ignore that for the moment. Here we are only now going to talk about C, C++ coding, which are in high level language. Okay, so first thing we require is a compiler to convert the C, C++ into ones and zeros, or in the machine understandable form, or in the machine language. So first we'll be converting that and we'll be getting object files. The object files are in ones and zeros. Then after converting that, we'll be giving that to a linker. The linker will be combining the three object files. Then we'll get a code that will be relocatable. The address has to reallocate. Then we'll be giving to that to a locator, and we'll get the final executable ROM image. Okay, so that's all for the compiling, or that is how we do the high level coding. Okay, next, the most important part of this video is actually this: the software development tools. I have actually seen a lot of competitive examinations in which they're asking regarding these tools. They'll be actually writing the definition of these tools, and they will allow you, or they'll ask you to choose the correct name of this tool. Okay, so that's why I have actually included this part here. First one is assembler, second one is compiler. We have actually seen these two terms, and also linker. The next one, loader, locator, editor, interpreter. Okay, let's see one by one. First one is assembler. Now what is the function of an assembler? We have already seen assembler is it is a tool which is going to convert assembly language codes or assembly language to machine codes, and the process is called assembling. Next one, compiler. That also we have seen compiler will be converting high level language to machine codes. See here, the first step is actually compiler or compiling. Okay, see here also. So that is a function of a compiler. Next one, linker. So the linker is actually going to combine the object codes. Here you can see. So the next tool is a linker. So the linker is actually going to combine the object codes, just like we have discussed with the diagram. See here, it is been given two object codes and also one library file. So if there is some predefined functions, the linker will also combine the definition of that predefined functions from the library file. Okay, so these things are being done with the help of a linker. So that is a linker. Linker is actually combining of object files and also attaching of the definition from the library files. Okay, next. And also it will be converted to the executable format. Okay, so that is a function of a linker. Next one is a loader. So the loader, we have actually seen what is a loader in the image. So the loader, it reallocates the code after finding the physical memory address at that given instant. So after you perform either assembling or compiling and then linking of object files together, the next thing we are going to do is reallocating of the code based on the physical memory address. So when these codes are converted to object codes and when we combine them together, the memory address or the memory will be vary. Okay, so based on that, we are going to reallocate the codes after finding the physical memory address that is present at that given point. And also it finds approximate start address of each byte. So for each code byte, the approximate start address also it is going to find. Okay, so this thing is done with the help of a loader. It is going to reallocate the codes based on the physical memory availability, and also it is going to find the starting address of the codes or the bytes, various bytes present in each code. Okay, next one is locator. So locator is actually, I have seen MCQ questions coming from these areas. That is questions connected with what is a loader, or you will be given the definition of a loader. You have to find which is that tool. Okay, next one is locator. Locator is actually, if you say it as a brief, locator is going to find the address on the row. Okay, so locator is locating the codes as ROM image. So we have seen that finally after conversion to the object code and then after linking and everything, we'll get a final code, right? Final executable code along with data that we are going to burn to the ROM, and it is called ROM image, right? Now this locator is going to locate the codes as ROM image. Locating the code means finding the address on the ROM or the available address on the ROM it is going to find, and it is going to place the final code to that address. Okay, so that process is done. That is finding the address is actually done with the help of a locator, and also it keep track of available address at every time. So the main function of a locator is to locate available address on the ROM space. So some space of the ROM will be consumed, some space or addresses of the ROM will be available. So the function of locator is to locate the available addresses on the ROM. Okay, next one is editor. I am sure that all of you have used at least one of the coding IDs, that is integrated development environment or softwares, either MATLAB or for Java, that is Spring or Eclipse or anything. At least Turbo C or C++ you have used. So in every these type of softwares, the place there where we are writing the code is called an editor window. So in that window we can, or in that tool, with the help of the editor, we can write the codes, we can edit or make corrections. Okay, so that is an editor. Next one is interpreter. So interpreter is used for line by line conversion to machine code. So after we write either assembly code or high level language code, we have to convert that to machine code, right? So with the help of an interpreter, we'll have line by line conversions. Okay. So in this video, I have included these topics. So these topics were from the software components of the embedded system. So till now we have covered the introduction, characteristics, hardware components and software components. Okay, next we are going to discuss about the design life cycle of the embedded systems. Okay, the RTOS will be actually discussing as a separate module. So in this video, I have not actually included the questions because every point that is for especially the tools that we have discussed, every point is actually a question. So you should be knowing at least the definition of every tools, and also you should be knowing how we are going to write the code in assembly language coding. Then after we are converted to machine codes, and also you should be knowing high level language coding, all these things. Okay. So I'm really hoping that you understood the concepts and you found the video useful. If yes, please should give it a thumbs up, also share it with your friends. And if you want more videos or if you would like to continue watching the series on embedded systems, please do subscribe to the channel. And also there is separate playlist for all the other important subjects. Okay, DSP, ITC, analog communication, digital, analog, electronics. For all important subjects, there are playlists. Okay, so please do subscribe to the channel. Thanks for watching and keep on watching.